StatMan! StatMan! Alright, StatMan is back, and I'm going over an old question from the AP exam involving a matched pairs design. And off of this question, we've got 9 different employees that are tested on how strong they are. They're right-handed adults, and they're squeezing a sensor. It's determining how much power they have at each hand. And first they squeeze with the right hand. It's measured how many kilograms they're squeezing, and then again with the left. And we've got calculated differences all given to us. Now the question could, because there's a lot of it actually listed, but as it comes down to it, the only area we've got to concern ourselves with is this row of information right here, the differences between the right hand and the left hand. Since we've got a matched pairs design, we've got dependent lists, because each person is responsible for the data that it's following below it in the column. So what we can do is we can go right to our hypothesis and provide statistical justification that there might be a difference between right hand and left hand in terms of strength. So it doesn't specifically say to use a hypothesis test, but this is exactly the way that they want you to work it out. We'll begin by saying that there is no difference between left and right. And I'm going to summarize that with just this statement right here. I'm not going to write them as separate means. I'm just going to talk about the difference between the two, since I'm going to be subtracting this list 1 from list 2 to get these differences. So we'll start off by saying that there is no difference. So I'm going to explain what that means here on the side. That the mean difference would be the mean kilograms squeezed with the right hand minus the mean squeezed with the left. So if both hands have the same strength, then we're going to be assuming that there's no difference between the two and that the difference will come out to be 0. If the right hand is stronger than the left, the mean difference will be greater than 0. And actually write out what that means right alongside here. Remember, always give the context in the question. This means that the right hand is stronger. So the first step's done is to actually complete those hypothesis statements. The second step is to condition check, state the confidence or state the significance level, and also name the test that you're going to be using. We've got a simple random sample of employees. We can assume that that's taken. We've got only 9 employees, which is nice because it's less than 10% of all possible employees that might actually work there. So our sample size is small enough. Unfortunately for us, it's a little bit too small because 9 is not greater than or equal to 30. So if we have outliers and we have something that's strongly not normal with our difference list, we would have that really don't have much weight behind them. So since this is the case, we should really check to make sure that this list right here is normal enough in order to continue. And it does say in the reading that we can assume that the differences are normal. So make note of that. The problem states to assume normal conditions. And what I did is, I didn't even notice it. What I did is I actually went to my graphing calculator and I actually typed in all the differences under list 1. And then I used the box and whisker graph to actually sketch out the difference list. And if you hit the trace command, you can actually dig up all the important numbers, the quartile marks, and actually sketch it on your paper. All right, so moving on, we're almost through with the conditions here. Or other thing is what kind of, well, first of all, that it's a dependent. It's very important. We've got dependent situations here, or dependent lists. So we're going to use a matched pairs t-test, or you could also state it as a one sample t-test on the differences between the two. And we'll set our significance level, let's say at 1%, and go on to step 3. Okay, in step 3, we're doing the calculations, and the good thing for us is we've got the calculator to do the dirty work for us. We've already mentioned what kind of test we're using. The third step, we can just use the commands on our calculator. If you're using the TI-83 or 4, plus we've got, by pressing the Stat button, you can slide over to Tests and choose a t-test. So what we're actually attempting to do here, a t-test. Or you can type in the information that we know. I typed into list 1, at least I do, and we're assuming that there's no difference between the two. And we're going with a positive difference, which is that item right there. And if you hit calculate, it'll give you all that juicy information that you need, including the t-score, which you could write down on your own. I'm not going to write it on the board. It also lets you know the p-value, and important that you capture all the essential things that are there. The p-value and drawing the curve is very, very important. So to help out a little bit here, I might as well write it down and not be a punk and avoid it. Actually writing down the important things. The t-score is about 5.4 standard deviations. You're using a t-curve. You want to make sure that you draw that. Anytime you calculate a p-value, draw the curve. Say what it is. Is it normal? Is it t? Is it chi-squared? Give the mean and standard deviations. And actually put on the t-score and shading to the right. So very, very slim chance of that actually happening. So see how I'm labeling it with my p-value? We have the p-value being very low, is 0.0003. And then we're on to our fourth step. Since the p-value is low, it's lower than the significance level of 0.01, we're going to reject the hoe and be in favor of the alternative hypothesis, and then throw in the context to the question. The alternative hypothesis is that there is a positive difference, so that right-handed adults are stronger with gripping strength with their right hand than their left hand. All right, one more example to go.